Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, which is grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you are welcome to call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You're always welcome to join me through the Zoom link that is shared by me, both your teacher and also your DEC. Our classes are scheduled on Monday through Thursday from 11 till 12 in the morning, and we are just wrapping up our 6th week of our 9-week course. Next week is March break, so we will not be airing all week. So our next class will be back on Monday, March 21st. So take a break next week if you're listening and join me again on the 21st of March. At this point, you should be submitting some work. So the support questions, the ones marked with a pencil icon, are not for marking, they're just practice. So you decide which ones and how many of them to do, depending on what your needs are. If you're understanding a concept, feel free to skip the questions. If you need more practice, let me know and I will send you more practice. The answers are at the back of your booklet, so check your work to make sure you're on the right track. However, mistakes have been found, so if anything isn't making sense, let me know and we can correct those errors. The key questions, the ones marked with the key icons, are the ones to submit for marking. So please do all of those questions, show all of your work, your steps and your thinking, so that I can really understand what you understand and what you're confused about or struggling with. If you only give me the final answer, I don't know where you've gone wrong if you go wrong, so I can't give you credit for what you do understand. There are 3 methods to submit your work for marking. The first method is to scan your work and send it in electronically. If you have a smartphone, on the iPhone Notes app, you can scan, or Android's Google Drive app, you can scan. If you need help to do that, I'm happy to show you how to do that, talk you through it either through emails or messages or on the phone. If you don't have a scanner or a smartphone, you can also just send me pictures and that's fine as well. Then you can email it to me at studentwork@nnec.on.ca and then CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger, or my name there is B. Slate Wahsa. Second method is to drop it off directly in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We're the big red building next to the post office, and we have a small white mailbox next to our side entrance that you can put it there. It may take me a few days, particularly because we're on March break next week. If you drop it off in the next day or two, I won't get it until we're back in the office starting March 21st, but then I'll get back to you as soon as I can. The third method is to hand it into your DEC, and your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. If you have any questions or concerns, please contact me. This is why I'm here. This is my primary role in my job, is to support you. So you can email me at bronwyn.slate@nnec.on.ca. That's spelled BRONWYN.SLATE. You can Facebook message me at B. Slate Wahsa. You can call and leave a message for me at the main office, and then I'll return your call. The number is 807-737-1488 or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. So I'll get back to you as soon as I can. If you'd like to connect with me through social media, both my Facebook profile and my YouTube channel have the name B. Slate Wahsa. So feel free to friend me on Facebook and subscribe to my YouTube channel. All of our radio Zoom classes are uploaded shortly after airing, and I share them on Facebook. So that's a great place to access the recordings of our classes. Also, there are short videos on my YouTube channel that explain common errors or confusing concepts. So things that you might be struggling with, that's a great place to check out first, in case you just need a little bit of help with something. If there's anything in particular, I'm happy to make new videos and put them up there as we go along. So please check that out if you need help. Math is a super visual subject, so just listening to us on the air is probably not going to really help you. It'll help a little bit, but being able to really see what I'm doing, how I'm organizing information, connecting to the visuals is really going to set you up for the most success. So either please join me through the live Zoom link, and even if you're not asking me questions, but just watching what we're doing is totally fine. Or watch the replays on YouTube to really make sure that you understand what's going on. If you don't have access to reliable internet, you can let me know and I can send you a copy of the videos on a USB key or something so that you can still access them even if you don't have access to reliable internet. That's fine. All right, we're on day 23 of our course, wrapping up week 6, and we are doing another Throwback Thursday, focusing on lessons 13 through 15. So as always, answering the question, why are we reviewing already? There are studies done that show that we forget things really, really quickly. We don't have, our brains don't retain information for very long. If we just learn it at one moment and then move on, we don't remember it very, very quickly. We forget it. And then we only retain about 40% or so in the longer run. So if we continue to touch back on information, then we don't forget it as fast and we don't lose as much information because we're reviewing it. So that's the concept behind going back on Thursdays to sort of quickly retouch some of what we've done. And so that hopefully in a few weeks when we're finished the course and you're ready to your exam, that it's not completely like, what did we do 2.5 months ago? I have no idea. Hopefully this sets you up for a bit more success. Okay, but first, as we always do, let's activate our brains with doing some mental math. We know I'm not a fan of the mad minutes. They were stressful things in elementary school and did not set us up for success. They just caused more anxiety and dread. So instead of doing that with our arithmetic facts, we work on developing strategies that we can apply to different situations and that we get comfortable with numbers. So our question today is 48 plus 34, and we're going to add up in chunks. So we've done something similar to this before, but it's just sort of, again, using friendly numbers. All of these are about figuring out what numbers are friendly for you to make things that most accessible. So for me, how I sort of think about this is if I were to visualize it on a number line, starting at 48, and then I'm say, okay, well, I'm going to jump just +2 to get to 50. And so then I took 2 away from my 34. And so now I have 32. So I can actually just jump. I don't have to do it in smaller chunks. I can just add 32 now, and I can get to 82. And so 48 plus 34 is 82. So doing that in even just that small jump and then a bigger jump, that was a big chunk that was friendly for me to do, managed to add those two numbers together. So that's the idea, is that you get to pick what chunks. They don't have to be the same. They don't have to be 5s, they don't have to be 10s. They can be whatever makes sense for you. All right, let's quickly recap just a rerun of all the different lessons that we've done, what we've covered so far, to remember, to help trigger a memory so that when we do some problems, we know what strategies we might be using. So lesson 1 was the transformations of quadratic functions. Lesson 2, the polynomials and factoring. 3, solving and graphing quadratic equations. 4, exponent laws. 5, simple exponential equations. 6, simple interest in linear growth. 7, compound interest in exponential growth. 8, compound interest formula. 9, loans and RRSPs. And lesson 10 was buying new and used vehicles and vehicle costs. So that was unit 1 and 2. And then unit 3, we worked on last week and this week. So lesson 11 was trigonometry ratios. 12 was the sine law. 13 was a cosine law. 14 was trigonometry and problem solving. And then 15 was creating nets. So we've covered 3/4 of the course so far. And we have one more unit to go that will start after the March break and cover in our last 2 weeks. And then we'll have a week of review as sort of our plan. All right, so the highlights, again, recapping, let's review what we've done this past week, and then a quick review of the topics from those other lessons. So for lesson 13, the highlights, this was the cosine law. So when do we use the cosine law? We use this when we know two sides and the contained angle, the angle between those two sides, or when we know all three sides. So then we have two formulas that we can choose from, but really both versions work in all situations. They're the same thing, just rearranged so that the algebra is simpler depending on what you're looking for. So if we're looking for sides, if we're looking for the side in a situation, then we use the formula that is c squared equals a squared plus b squared minus 2ab cos c. Or if we're looking for angles, then we use the formula cos c equals a squared plus b squared minus c squared all over 2ab. Again, you do not have to have these memorized. They will be on a formula sheet for your exam. However, you will know which one. You will need to know how to apply it. I won't be telling you when to use the cosine law or which one is for sides and which one is for angles. This makes it easier. I will just give you the formula and call it the cosine law so that you know that, but you will have to figure out how to apply it. And for all the trigonometry pieces is that your calculator must be in degrees. Generally, our calculators always stay in degrees. They don't affect any of the other math that we do in this course. So it just makes sense to leave it in degrees. But if your calculator is not in degrees, then this will definitely affect you when you're doing anything with trigonometry. All right, so then lesson 14, the highlights. So this was trigonometry and solving problems. So the first thing that we were trying to figure out was that we needed to identify which trigonometric strategy we needed to use. So we had the three that we could choose from, which was primary trigonometry, which was the SOHCAHTOA, where we have right angle triangles. We use the sine law when we know two angles and one side, or when we know two sides and the one angle that is opposite one of the known sides. Or we use a cosine law, which is when we know two sides and one contained angle, and then three sides. We talked about the angle of elevation, which is the angle from sight level, from straight out to the horizon and then up to an object, and the angle of depression, which is when we look from straight out to sight, from sight level to the horizon, then down to an object. So that's important to know when we are interpreting our problems. And then finally, lesson 15, the highlights for creating nets. A net is a flat version of a 3D object that can be folded to create that 3D object. A pattern is a flat version of a 3D object where the parts are separated and then need to be reattached to create your 3D object. And a plan is a flat version of a 3D object that shows the front, side, and top views so that it can be constructed. All right, so then a quick recap of Unit 1 highlights. So lesson 1, the transformations of quadratics, where A tells us the opening direction, H tells us the horizontal shift, and K tells us the vertical shift. Lesson 2 is polynomials and factoring, where expand means to multiply according to the distributive law, and factor means to find the two binomials that result in the trinomial product. Lesson 3, solving and graphing quadratics, where solving a quadratic means what values of x result in y equaling 0. So this is the zeros or the x-intercepts. Lesson 4 was the exponent laws, where when you're multiplying two powers with the same base, then you add your exponents. When you're dividing two powers with the same base, you subtract your exponents. When you have a power of power, you multiply your exponents. The zero exponent law is that anything to the exponent 0 equals 1. And the negative exponent law is anything to a negative exponent, you do the reciprocal of the base. Again, if those are confusing, go back to lesson 4 and check that out. Or go to the channel. There's a few more videos up there explaining those in specific detail. Hopefully that will help. And finally, Unit 1, Lesson 5 was the simple exponential equations, where y equals ab to the exponent x, which is very fast change of either growth or decay. All right, and then the Unit 2 highlights. So Lesson 6 is a simple interest in linear growth. The pattern increases or decreases at a constant rate. I equals PRT, and A, the final amount, equals our principal P plus our interest I. Lesson 7 was compound interest and exponential growth. The pattern increases or decreases at a constant ratio. So A equals P times 1 plus R over N, all to the exponent NT. And your interest is found by Your interest amount is found by the final amount to take away the principal. And lesson 8 was a compound interest formula, where we were looking at situations that included the word compound. We're talking about compounding, where we had to rearrange our formula to find either the principal, the interest rate, or the time. And we used the nth root and the guess and check strategies to solve for the interest rate and the time values. Lesson 9 were the loans and RSPs. So this is when we had lots of formulas. So loans are when we're borrowing money and we're paying back plus interest. And those payments are calculated based on the amount that we borrow, or the amount that we borrow is based on the amount that we can afford to pay back. So we have these two formulas: PV equals capital R times 1 minus, open a bracket, 1 plus I, close a bracket, the exponent negative n, close a bracket, all over I. And then the payment is equal to R equals present value, PV times I, all divided by 1 minus, open a bracket, 1 plus I, close a bracket, to the exponent negative n, close your bracket. It's really, really important to remember your order of operations, and remember that you need to do 1 plus I first, and then to the exponent negative n, and then subtract that from 1. You can't just do 1 take away 1 and they cancel off, and then do I to the negative n. That's not going to work. That's why we have these brackets in place, because we need to do what's inside the brackets first, then we do the exponent, and then we do the subtraction. Really, really important. And then we also have RSPs. Sorry, mine. Are set up to give you regular payments once you retire. The more that you invest earlier, it helps you have more money in the long run. So if you're making contributions, we had formulas where your amount is equal to your payment, R times 1 plus I to the exponent n, take away 1, all over I, or your payment amount is equal to your total amount, A times I, divided by 1 plus I to the exponent negative n, take away 1. I think that that's not supposed to be a negative n, that's supposed to be a positive n. This is why these are really important to check and be comfortable with this is why we don't have to memorize this, because it's easy to mess them up. And then receiving payments is just like in terms of loans. Those payments are the same. Those formulas are the same. Then lesson 10, the buying new and used vehicles and vehicle costs. So when buying a new vehicle, we learned how to calculate the payment and complete a deal review. For buying a used vehicle, we learned how to calculate the depreciation value. And then we also talk about the cost of owning a vehicle, calculating fuel costs and how much fuel is consumed, how much it costs, and then calculating monthly averages to make a plan for how much you're going to spend on vehicle costs. And then finally, unit 3 highlights. We've done a lot, so there's a lot to review. Trigonometry ratios are sine A equals opposite over hypotenuse, cosine A angles equals adjacent over hypotenuse, and tan of an angle equals opposite over adjacent. The lesson 12, the sine law, is when we have two known angles and a side, and we know two sides and an angle that is opposite one of the sides. Equals sine B over B equals sine C over C, where the sides equals A over sine A, B over sine B, and C over sine C. All right, and that's everything that we've covered so far. It's a lot, but that's why we continue to review. So let's dive into some practice so that we can actually apply what we've been learning. All right, so these questions are all mixed up. We need to figure out what strategies we need to use and then how to actually solve the problems. So number 1, Dante is a forensic scientist who examines crime scenes. A bloodstain is 9 millimeters wide and 18 millimeters long. At what angle did the blood hit the floor? So this is looking for the angle of impact. We have not done this at all, but when I was looking at questions to include, this came up as an actual application. I thought it was interesting. So the angle of impact isn't something that we know, but it's defined as sine A equals width over length. So it's defined as a sine ratio is how you find the angle of impact. So what we can do for this question is to figure out the angle of impact. So how, at what angle the blood would hit. So sine equals A equals width over length. So the width was 9 millimeters over the length, which was 18 millimeters. So sine A equals, well, 9 over 18 is 0.5. And then because we have sine A equals a decimal, we need to figure out what angle A is. I was talking to a student yesterday who didn't want to write all the steps out. So if you wanted to, you could do angle A equals sine inverse of 0.5. Instead of writing sine inverse on both sides, this is one way that you could do the shorthand that is mathematically accurate. So then if we look at our calculator, so we're looking to do sine inverse of 0.5 equals 30 degrees. So the angle A is equal to 30 degrees. So we have to make sure we've answered the question. At what angle did the blood hit the floor? So the blood hit the floor 30 degrees. So this, I tried really hard to like draw a triangle to figure out how that looks. It doesn't look exactly the same as the triangles that we were used to, so that's why I didn't include it. But this is an application of trigonometry that is actually used in the world in terms of forensic science and criminology. So I thought that was interesting to see it played out in a different world. All right, question 2. A rectangular pool is 6 meters wide and 10 meters long. A concrete deck of uniform width is to surround the pool. A, sketch a diagram and label it to represent the pool and the concrete deck. So let's start with that. So we need to sketch it. So we know that we have a rectangle. Here we have one set of sides longer than the other. So we're 6 meters wide and 10 meters long. We have a deck that goes around it that has a uniform width. So that means that it's gonna look something like this. And we're just gonna we're gonna call the width, let's just call it X. And so it's gonna be X both in this direction and X in this direction because it's uniform, it's the same width the whole way around. So that's what we've done for part A. We've sketched it and we've labeled our diagram. So then B, write an expression for the total width and the total length of the pool and deck. So the width is this, so we need to include both the pool and all the way across both parts of the concrete slab. So it's going to be 6 meters, so that's the pool, plus X plus X. Sorry. So that's going to be 2x plus 6. You can write it as 6 plus 2x. I'm just writing it 2x plus 6 as we often write the variable first. And then the length is our 10 meters direction plus also plus 2x. So it's 10 meters plus x because the pad goes around, concrete path goes around both sides. So then again, we have 2x plus 10. Right, so that's part B. So then part C asks us, it says, if the total area of the pool and deck cannot exceed 320 meters squared, what is the greatest possible width of the deck? So this is a little bit different. So we're trying to figure out the width of the we're trying to figure out X, and we know that the whole area can't be 300 and more than 320. So let's think about the area of a rectangle is equal to our length times our width, right? So our area is going to be 2x plus 10 times 2x plus 6. And that has to equal, it can't equal more than 320. So we're going to set it equal to 320, and then we know we're going to solve for x, and it has to be smaller than that. So I'm going to expand my two binomials. So 2x times 2x is 4x squared. And then 2x times 6 is 12x. And then 10 times 2x is 20x. And then 10 times 6 is 60. So then I'm just going to combine. So I get 320 equals 4x squared plus 32x plus 60. And then I'm going to rearrange this so that I can find my zeros, right, in order to find my x values. So I'm going to have 0 equals 4x squared plus 32x plus 60, take away 320. And then I'm going to simplify that. 4x squared plus 32x and 60 take away 320 is negative 260. So then I need to solve for x. We have that coefficient of 4, right? So we need to check to see if we can factor 4 out. We probably can. So factoring 4 out, we get x squared plus 32 divided by 4 is 8x. And then negative 260 divided by 4 is negative 65. So now we need to figure out what are two numbers that multiply to be negative 65 and add to be 8. Back to our factoring. So we have to figure out our factor pairs. So 1 and negative 65, negative 1 and 65. Guess 65, I'm going to say, I don't know the factors of that, but it's going to be divisible by 5. So 13 and negative 5 and negative 5 and sorry. That's the same thing twice, just reverse the order. Negative 13 and positive 5. Well, I know that 13 take away 5 is 8. So this is going to be my pair. So then I can, done that thinking, I can go back to my equation. 0 equals 4 times x minus 5 times x plus 13. So I'm going to go up here. I'm running out of space. So that means that either 4 equals 0. Well, that doesn't make any sense. So that's not going to help us. X minus 5 equals 0, or x plus 13 equals 0. So x minus 5 only equals 0 when x equals 5, and x plus 13 only equals 0 when x is minus 13. Well, we're talking about a distance, so we can't have a negative distance because it doesn't make sense to have a negative width on our concrete pad. So x can equal negative 13. So x equals 5. So then we have to check to make sure what the question is asking. What is the greatest possible width of the deck? So the greatest, sorry, I spelled that wrong, possible width of the deck is 5 meters. And there we go. So it had some steps to do it, got a little bit squishy, but that's how we were able to answer that question. All right, number 3. 3 cell phone towers form a triangle as shown below. Calculate the angles between the cell towers. So we have a triangle that I've labeled X, Y, Z, and side Z which is between points X and Y, is 16. And then the side Y, which is between points X and Z, is 19. And then the side X, which is between Z and Y, is also 19. So because we know we have three sides, we don't have a right angle triangle, because we know we have three sides, the only tool that we have to use is the cosine law. So we're going to use the cosine law to solve this problem. So remembering the cosine law is asking us to calculate the angles. So it wants us to calculate all of the angles. So we can pick any angle that we want to in order to figure it out. What I've noticed is this is an isosceles triangle. So this side and this side, my side X and Y are the same. So that means that my angle at X and Y are the same. So I'm going to actually solve for Z, because it's going to just make my life easier later. You could totally do the exact same thing and solve for X and then solve for Y and then solve for Z and do the cosine law 3 times. But this way I'm going to use some information that I know to do it a little bit of a shortcut. You don't have to do it this way. You could do the cosine law 3 times and it would totally give you the same answers. So I'm going to solve for angle Z. So that is cos Z equals x squared plus y squared minus z squared all over 2xy. So cos Z is equal to 19 squared plus 19 squared minus 16 squared all over 2 times 19 times 19. Going to get our Desmos calculator out and do 19 squared plus 19 squared minus 16 squared. All of that, remember when all of that divided, so we could put it in brackets, or we could do just select it. 2 times 19 times 19 equals 0.6454. So cos Z equals 0.6454, I believe is what it was. Just going to check to make sure. 6454. Perfect. Okay, so then to find angle Z, again, I'm going to show you the short form in case you want to write the short form. Instead of writing cos inverse of cos Z, we can just write angle Z equals cos inverse of 0.6454. And so angle Z equals, go back to our calculator, and we're going to do cos inverse of 0.6454, and that equals 49.8, so 50 degrees. So angle Z equals 50 degrees. So then the quick way to do this, again, you could do the cosine law. You could do all of these steps, again, solving for Y and then solving for X, totally fine. The other way that you can do this is that I know in a triangle, we have 180 degrees. So 180 degrees, take away 50 is going to be 130 degrees. So these two angles, angle X and angle Y, add up to 130 degrees. I know that they are the same because this is an isosceles triangle. You might not know that. So you could just use the cosine law to solve based on what we've done in this course. But I know, and I think you should know, that those angles are the same. So because those angles are the same, I can just divide this 130 degrees by 2. And that's going to be 30 divided by 2 is 15. 100 divided by 2 is 15. So that's going to be 65 degrees. So angle X and angle Y are both 65 degrees, and angle Z is 50 degrees. And that's how you could solve a question like this. So sometimes you need to do all of the work. You need to do the cosine law 3 times, depending on if one of our sides had been a different length, had it been 17 kilometers, then we would not have an isosceles triangle and we'd have to do it out 3 times. But sometimes you can use other information that you know, and that is totally fine. It is okay to do the question in different ways than how I do it, and in different ways than how your peers do it. It's totally fine. Sometimes there's more than one way to do the question. So that's just to show that. And then also practice the cosine law. All right, question 4. A used car is purchased and a $10,000 loan is taken. The loan is for 3 years, so 36 months, and the interest rate is 8% compounded monthly. What is the monthly payment? So we're looking for the monthly payment for a car. So we are going to go, this is remembering our monthly payment. We're going to look it up because I don't know it. So monthly payments for cars are, which is the same as any loan. So capital R equals PV times I all over 1 take away 1 plus I, where 1 plus I is in brackets because then it's to the exponent negative n square brackets. So then we need to figure out what we know and what we don't know. So R, PV, I, N are our variables that we need to fill in. So R is the monthly payment. That's what we're looking for. PV is $10,000. Our present value, how much we borrowed, is $10,000. Our I is 8%, so 0.08 compounded monthly, so divided by 12. And our N is our total number of payments, which is 3 years, but the monthly payments, so it's 36 because it's 3 times 12. So now we're going to substitute in our values. So R equals 10,000, 0.08 divided by 12, all over, open bracket, 1 plus 0.08 over 12, close a bracket, to the exponent negative 36, close a bracket. And we're going to use our handy dandy Desmos calculator to do all of the thinking for us. So that is 10,000 0.08 divided by 12. All of that divided by 1, take away, open bracket, 1 plus 0.08 divided by 12, close a bracket, to the exponent of 36 equals 70.93. So our payment is going to be, so over 3 years, our payment is going to be $70.93. So the monthly payment is $70.93. There we go. Of finding a payment. All right, number 5. A shed is 8 feet wide. One rafter makes an angle of 30 degrees with the horizontal on one side of the roof. A rafter on the other side makes an angle of 70 degrees with the horizontal. Calculate the length of the shorter rafter to the nearest foot. So these questions, I strongly encourage you to draw a picture so you can visualize it. So we have a shed that is 8 feet wide. The roof, so we know that one rafter makes an angle of 30 degrees and the other rafter makes an angle of 70 degrees. And we are trying to calculate the shorter side, the shorter rafter. So we have just label our triangle ABC for the sake of ease. So A at the top, B at the side that has 30 degrees, C at the side that is 70 degrees. We are looking for side B, that's the shorter rafter. We know side A, that's the 8 feet. That's how wide our shed is. So we need to know what side, angle A in order, because right now we have a side and 2 angles. So that means that we need to have the angle across from the side that we know so that we can use the sine law. So angle A is equal to 180 degrees, take away 30 degrees, take away 70 degrees, is equal to 100 degrees, because 30 and 70 is 100. So sorry, not 100, 80 degrees. But my brain was getting ahead of my hand was getting ahead of my brain. So angle A is 80 degrees. So that helps us so that now we can do the sine law. We're looking for a side. So we're going to do B over sine B equals A over sine A. So B is what we're solving for. So B over sine 30, because angle B is 30, is equal to 8 over sine 80. So then B is equal to sine 30 times 8 over sine 80. So B equals so we have sine 30 times, that was going to put my, sorry, just want to make sure that I'm not timesing my angle by 8. That's something different. Times 8 divided by sine 80. So that equals 4.06. So B equals 4.06. Then we have to figure out what the question's asking. So calculate the length of the shorter rafter to the nearest foot. So the shorter rafter is 4 feet. There we go, we're done. All right, number 6. A tent is the shape of a triangular prism, as shown below. How much canvas is needed to make the tent, including the bottom? So we're assuming, don't worry about the seams or the flaps or whatever. We're just assuming that this is a triangular prism, but it's a tent, because that sort of is basically the same thing. So we have a tent that is showing it's got our various lengths and heights, and we need to figure out how much canvas is actually needed to build this. So I'm going to draw a net so I can see all of the shapes that I need. And when we did this previously, we found that doing it with colors really made it a lot easier to help to see what it was. So I know that my base is going to be 8 feet by 12 feet. That's how much the bottom of my triangle is. And then my other side is 6 feet going up. So we're going to use that information to help us figure out what our net is going to look like and go from there. So I'm going to start with thinking about the bottom. This is how I visualize it. So I'm going to say, okay, so my bottom is I have 8 feet by 12 feet. as we know, my drawings are absolutely beautiful. So no worries about it being perfect. And then we have from there, we have, so that's the bottom. And then if I cut my tent and flatten it out, I'm going to end up having this, the sides of the tent are going to lay flat. If I were to cut along the top, they would lay flat down. So that means that I'm going to have 6 foot sides. Either side is sort of how I visualize it. And those are 6 feet by 12 feet. So now we have the bottom and the 2 sides. And now we need to think about the triangular front and back. So they are 8 foot sides of my tent, and they are going to go up like this and up like that. And so now we're going to label our sides. Again, color coding it really helps me. So I know that this is 6, 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 6, 6, and 6. And then this part here is 8, and this part here is 8. And then all of my blue lines are 12. So I can also figure out what lines are touching. And like if when I were to put it back together, I can see that this line and this line would be touching, and this line and this line would be touching. So that really helps me visualize it, color coding it. You don't have to do it that way, whatever works for you. All right, so then we need to figure out how much canvas all of this is, which isn't what we haven't done that before, but it's a good application of a net. Having just a net isn't all that useful. So we have a triangle here, sorry, we have a rectangle with a width 8 and 12. So that's our bottom of our canvas. So the bottom is a rectangle that is 8 by 12. So the area is 8 times 12. So 8 times 12 is 96 feet squared. So this is the bottom. And then we have the sides that go up. So the sides are the same. So there, 2 of them are the same, and they have, so the area is a rectangle, so it is 12 by 6. So 12 by 6 is 72 feet squared, and that's 1. So we need to have, so we have 2 sides. So we would need to have 2 times 72 feet squared. So that would be 144 feet squared for our 2 sides. And then our third shape, our triangular front and back is the same. So I'm just going to call it front. This is the same. So front and back. So that's a triangle. And so here we don't, this one's tricky because we know the sides, but we have to look back at our original thing and we see the height is 5 feet. So that is actually in terms of figuring out the area of that. We need to know that that's 5 feet. So the area of a triangle is base times height divided by 2. So that is 8 times 5 divided by 2. 8 times 5 is 40, divided by 2 is 20 feet squared. But then we have 2 front backs. So we have 1 front and 1 back. So 2 times 20 is equal to 40 feet. So then the total is going to be all of them added up. So the bottom plus the 2 sides plus the 2 front back pieces. So the bottom was 96 feet squared plus 144 for the 2 sides feet squared and 40 for the front and back, the triangular part, feet squared. So 96, use your calculator to make sure I get it right. 96 plus 144 plus 40 equals 280. Feet squared. So make sure we've answered the question. How much canvas is needed to make the tent, including the bottom? So 280 feet squared of canvas is needed to make the tent. So that's how an actual application of a net is actually useful in the world. All right, question 7. Jackie is an engineer and determining the length of a tunnel through a mountain. They choose a point facing the mountain and then measure the distance from there to one end of the tunnel to be 840 meters and to the other end of the tunnel to be 760 meters. The angle from that point to the end of the tunnel is the angle from both points to the end of the tunnel is 62 degrees. Calculate the length of the tunnel. So again, visualize it. This is a little bit confusing. So we have a mountain. We have a point, and we have a tunnel through the mountain. Again, I draw really beautiful diagrams. So from one end of, from that point to one end of that tunnel is 840 meters. Again, this is not going to be to scale or perfection at all. So then from that same point to the other end of the tunnel is 760 meters. This is just for me to visualize, not for me to have an exact scale model. That's something else. The angle between those two distances is 62 degrees. In theory, a surveyor or an engineer will be able to measure all of this with their tools. So how long is the tunnel? So we have two sides and a contained angle. That means we can do the cosine law. So we're just going to label, I'm going to call my tunnel T, and my other 2 points R and S. So the cosine law, we're looking for a side length. So we're looking for T squared equals R squared plus S squared minus 2RS all times cos T. So T squared equals 840 squared plus 760 squared minus 2 times 840 times 760 all times cos 62. So we're going to get our calculator. And we have 840 squared plus 260 squared minus 2 times 840 times 760 times cos of 62 is equal to, and then I am just going to, I know I need to take the square root of that value. So because I'm here, I'm just going to copy and paste it here instead of rewriting it out because we're short on time. And so our tunnel is going to be 826 meters, so 0.9. So we're going to say 27, sorry. So T equals 828 meters. So I just did all of that on my calculator just for the sake of time. So the length of the tunnel is 828 meters. And there we go. That's how we answer that question. All right, so unit 3 is now completed. So please start submitting your lessons 1 through 15 if you haven't already, as well as lessons 1 through 10. So remember to do the key questions. So they are the ones to submit, do all of them and show all of your work so I can give you all of the credit. As always, if you have any questions, please contact me. Call me at the office, 807-737-1488 or 1-800-667-3703. You can email me at bronwyn.slate@nnec.on.ca or call or Facebook me at bslate Wahsa. Remember, next week is March break, so we will not be here. We will be back on March 21st First, I hope you have a lovely break and hopefully we get some spring weather and can enjoy that. This will be up shortly this afternoon on YouTube, so you can check it out there again if you want to review some things. I hope you have a lovely day. Thank you for joining me. Miigwech.